In this lecture, we'll look at factoring quadratic expressions, and this is going to focus on the simple case. Now, we're going to start off by understanding what quadratic expressions are. We're going to use the product and sum method, where the coefficient of a of x squared is 1, and then we're also going to look at the reverse distribution property method, where a is greater than 1. Once we get into the video, you understand the concept of a, what a really stands for. So, quadratic expression, this is the format ax squared plus bx plus c. Remember, because it's an expression, you don't have the equal to. In this case, we're going to look at a is greater than 0. Ideally, a should not be equal to 0, so a cannot be equal to 0, because a could be negative as well as positive. It just cannot be 0. So let's look at a few examples. So 3x squared plus 2x plus 1, that's an example. 5x squared plus 1 is an example because b could be 0. The only thing that cannot be 0 is a. And then we could also have 6x squared plus 3x. This is also quadratic. So these are just some examples of quadratic expressions. Now we're going to look at the product and sum method for instances where a, which is the coefficient of x squared, the number to the left of x squared, must be 1, which means for the most part there's no number there. And we're going to use the product and sum method. So here's how the product and sum method works. So we're going to look at the quadratic term and the constant. So in this case we have negative 15x squared. Now we're going to look for the factors of negative 15x squared that add up to negative 2x. So if we look at negative 15x squared, let's look at potential factors 1 and 15. And because it's negative, one of them has to be negative. We have 1 and 15. Let's put an x here because we're dealing with x squared. And we have 3 and 5. So I'm going to put a negative here. And then 3 and 5. Ideally, you don't have to deal with the x if you don't want to. So we can see that negative 1 and 15, there's no relationship that gets you to 2. So now we're going to focus on 3 and 5. So we can see there's a relationship there that can get us to 2. Now, because this is negative 2, it means that the negative sign will have to be on the larger number. So this is going to be our set that we're going to use. So I'm going to open up parentheses. So I have x right here because I'm going to deal with x squared, and then I have minus 5 plus 3 because that's the set that actually leads us to negative 2. Let's look at another example. So we have x squared and negative 10. So I'm going to just ignore the x squared in this example. We have negative 10. We have factors are 1, 10, 2, 5. Because it's negative, I'm going to have another set. So let's put a negative here, negative here, negative here, negative here. So we need to look for which set gives us a relationship that leads to 3. This does not, this does not. So we have, because it's positive here, negative sign will have to be on the smaller number. So this is going to be our chosen set. So we're going to have x, we have minus 2 plus 5. So that's pretty much how you deal with this type of equations. Let's try one more of this type with the a equal to 1. So we look at x and 12. So 1 and 12 is going to give us 12. Now to pay attention to the fact that this is negative. So that means that both factors have to be negative for us to get a positive product. So we have 1, 12, 2, 6, 3, 4. So both have to be negative. So which of this set of negative pairs will give us negative 8? It's going to be this right here. So we open up our parentheses, x minus 2, x minus 6. Now let's get to an example where we have a greater than 1. So we're going to start off at the same point. 2 and 6 is going to give us 12. And we have a negative 7 here, so we know that our factors have to both be negative. So we have 1, 12, 2, 6, 3, 4. So which of them leads us to a negative 7 outcome? This right here. So what we're going to do now, this is where it's a little bit different. What we're going to do now is we're going to replace negative 7x with negative 3x and negative 4x. So this is how that goes. So this is 2x squared. Instead of negative 7x, we're going to say minus 3x minus 4x plus 6. So what we've done here is we've replaced negative 7x with these factors here. And then the next step is we're just going to group them together and then factor each of these groups. So here we have 2x squared and 3x. X is a good factor here. And so we're going to divide each of the terms in the parentheses by x. So this is going to give me 2x minus 3. And then we have negative 4x and then 6. Whenever you have a negative, the safest thing to do is to actually divide by a negative number. So I'm going to just divide by, I'm going to have minus 2 as my factor here. So negative 4x divided by minus 2 is going to give me 2x, and then we have minus 3. Now this is very important. This is an important thing to remember. Now when you're done with your, I call it the reverse distribution, you want to make sure that the terms in the parentheses are exactly the same, because what you're going to do is you're going to first single them out to x minus 3 and then x minus 2. You can see that using the law of the distributive property, this is the same as x multiplied by 2x minus 3 minus 2 multiplied by 2x minus 3. That's what you see here. Finally, we're going to take a look at this example. So we have 3x squared and negative 8. So we're going to deal with negative 24. Negative 24. And we're going to look for factors of that that lead us somehow to 8. Because this is negative and this is positive, that means that one of your terms must be negative. So we have 1, 24, 2, 12, 3, 8. So we already see that 3 and 8 have some form of a relationship that lead us to a 5. And because it's positive, we're going to put the negative on 3. So now we are going to rewrite this as 3x squared minus 3x plus 8x minus 8. And so we're going to group them and factor. So 3x squared and minus 3x, common factor there would be 3x. We have x minus 1, and then we have 8x and 8, So plus 8x minus 1. So we have a check, x minus 1 here, x minus 1 here. If you find that the factors in the parentheses, the term or the expression in the parentheses, if you find that in your case it's different, then you've done something wrong. So now we have x minus 1 because that's what's common, and then we have 3x plus 8. So these are the two methods that you would use to, these are the two scenarios that we can consider. This scenario that we're looking at right now for a greater than 1, it would also be fine for a that is less than 0.